With the rising usage of artificial intelligence in critical applications such as self-driving cars, AI is becoming an increasingly important part of our lives. More specifically, self-driving cars rely on a type of artificial intelligence called convolutional neural networks, which can be thought of as a network that allows an AI to see. However, these convolutional neural networks, or CNNs for short, have a problem. Current CNN algorithms require tremendously large amounts of data to classify images successfully. In practice, collecting large amounts of data is both time-consuming and expensive. As a result, most CNNs are trained on incomplete datasets which don't fully represent the real world. Due to this effect, CNNs are often vulnerable to making errors due to minor variations such as scratches or dust on signs. For applications such as self-driving cars, where incorrect decisions can have disastrous consequences, CNNs must be made resilient to these sources of error. One possible solution to this problem is the adversarial self-driving framework. This framework has three parts: a classifier, a generator, and a discriminator. The classifier is a CNN responsible for making decisions, for instance, classifying a traffic sign. For the adversarial self-driving framework, a classifier is provided with some base examples of different types of signs, and has to determine the type of the sign. The generator is a CNN that takes an image and applies some minor changes to it. The generator makes changes with two objectives. First, it has to make changes that cause the classifier to misclassify the image. And second, the generator has to ensure that the changes it makes to the image are realistic. The discriminator is responsible for determining if the images are realistic. It learns from a set of natural images from the original dataset and a set of images modified by the generator. This process works because at each iterative step, the generator identifies examples of where the classifier makes mistakes and creates new, similar examples from which the classifier can learn. Since the generator's objective is to ensure that the discriminator determines that altered images are from the original dataset, it ensures that modifications to the image must be realistic. This framework can be thought of as a three-player game, where the classifier must learn to identify images, and the generator tries to create new examples of images that cause the classifier to make errors, with the discriminator ensuring that all images are realistic. This game continues until the classifier can correctly identify all realistic images modified by the generator, at which point it will have a generalized understanding of the dataset. The adversarial self-driving framework provides a viable method to improve the numerous AIs which have an increasingly important impact on our lives.